Welcome back to Physics 142. We've been talking about the different elements in circuits, and in the last video I introduced the idea of batteries, power supplies, and electromotive force. And so in this video, I just want to do a couple quick examples involving batteries, power supplies, electromotive force, and the concept also of resistors and sort of the power that gets dissipated by resistors. So, just as a way of remembering sort of the formulas that we have, all right, we could think about for some power supply, maybe it applies some amount of power, but let's think about a copper wire, maybe a copper wire that has a resistance. So let's think about a copper wire that has a resistance of 1.05 ohms, all right, 1.05 ohms. That's a copper wire. And I did an example in an earlier video where we calculated a copper wire that had that amount of resistance. All right, and let's imagine then that the power supply supplies in a certain amount of power. The power supply in this circuit gives us a potential difference of 1.75 volts. So if we think about, so here's our power supply, and let's say the actual amount of power that comes out of that power supply, all right, is 1.75 volts, right? So if we do that, and then we have a resistor here, which has 1.05 ohms, then the question is, how much power gets dissipated by this resistor? Find the power dissipated by the resistor. All right, and well, how do we work that out? Well, we have to go and look at our different power formulas, right? So the formulas we had for power, we had that power is V times I. We also had that power for a resistor. Well, we know resistance, right? So we also had I squared times R. Well, we don't actually know I here. We could calculate it using V equals IR, right? But the other way that we combined these two formulas is we said, oh, well, P, if we just know V and R, P is going to be V squared over R. So there you have it. We can plug in the numbers, right? We plug in 1.75 volts. That will get squared. We plug in 1.05 ohms down here, and we get an answer, an amount of power that will come out in watts. I think the answer is something like 2.92 watts worth of power from this particular circuit. All right, so if I was trying to light a 100-watt light bulb or something like that, not enough power to do that here. All right, but you do dissipate a decent amount of power just from this wire here. All right. Okay, so that's just an example of finding power using these power formulas. Let's do another example where we think a little bit about internal resistance and EMF. All right, and so let's say that this 1.75 volt battery, all right, actually has an EMF of 2 volts. All right, so the EMF in this battery, let's say the EMF is actually 2 volts. All right, and so then the question there might be find the internal resistance in that battery. All right, well, how are we going to find the internal resistance? Well, first of all, we need to know, we need a formula, and the formula that connected the potential that actually came out versus the EMF that went in was, well, it's the EMF minus the current times internal resistance, R, right? So solving this for internal resistance, well, that's pretty straightforward. We do V plus EMF, right? V plus EMF, that would give us minus I times R, right? So then we divide through by minus I, divided by minus I. That will give us R, right? Or if we, that's V minus EMF, really struggling here, right? I move this over to the other side, V minus EMF divided by minus I, or so we could write that as EMF minus V divided by I, right? Just dividing both sides there by -1, or multiplying them both by -1. So, well, we know EMF, that's 2. We know V, that's 1.75, right? But we don't know the current necessarily, so we need to go back and actually calculate the current. Conveniently, we can do that, right? The current is just going to be V divided by R, and we know V and R, right? That's going to be 1.75 divided by 1.05, and when we do that, we get 1.67 amps, right? Volts, ohms here, so 1.67 amps. So now we can just plug in the values over here, and we're going to get that internal resistance R, the little internal resistance R, is going to be 2 volts minus 1.75 volts divided by the amount of current, 1.67 amps, and that comes out to an internal resistance of 0.15 ohms. All right. Now, as a follow-up question, I could add here, how much power would you have to input into the circuit to maintain a current of 2 amps if I added a 10 ohm resistor? All right, so let's, sorry, I just read my question without actually thinking about it. So, let's have a look at this though. So I should state the problem more clearly. Let's so what if I change the problem a little bit? So now this is all well and good, all right? But what if I take this system now, we've calculated internal resistance, we've calculated power, all right? And let's change the system a little bit. All right, I want to change the system a little bit. I'm going to add another resistor. Okay, so let's go ahead and look at another example here. All right, where here is our other example, where now I'm going to take and I'm going to add another resistor. So we'll have 2 resistors, right? We've got the resistance in the wire. That was 1.05 ohms. And now I want to add a 10.00 ohm resistor to this wire, and let's say that I wanted to maintain a current of 2 amps. All right, so this is another example here. All right, so let's say I want to maintain a current of 2 amps, and remember that the voltage across this is still our 1.75 volts, I think, but we don't actually even need that here, right? Because what we can do is we can look at this and we can look at this problem and we can say, well, if I want to know the power that I need to actually input here, right? The power that I need to input is going to be I squared times R, right? I squared times R. And so, well, I squared, that's going to be 10, that's 2 amps, right? I squared here is 2 amps, that will get squared. And then the amount of resistance, well, if we're using that same battery, all right, that had a little internal resistance of 0.15 ohms, then we would need to add that in, so we would have 10 plus 0.15 plus 1.05 ohms, all right? So if we have all of this together, then you can go ahead and calculate that, right? That's going to be 4 times 11.2, right? And 4 times 11.2, that's going to be about 45 watts. So, you can, the point here is that you can, rearrange these in a bunch of different ways, but using these formulas all together, we can calculate different amounts of power inputted and power dissipated away.